The world has long been talking about human desire, a great and mysterious storm that humbles and challenges our understanding of the world. The universe, as we know it, is a dynamic, evolving entity, a place where the laws of physics govern the dance of galaxies, stars, and planets. But in this great ball, there are still mysteries, some of which defy explanation for generations. Now, with the arrival of the James Webb Space Telescope, JWST, these mysteries are getting more attention and, in some cases, changing. In the discovery of a new Earth, JWST has provided an image that has sent shockwaves through the world of physics. This is not a picture of a distant galaxy or an unusual set of stars. It's a visual, game-changing story that promises to change the way we understand the world. Despite the beauty of this phenomenon, it also has negative aspects, challenging long-held beliefs and provoking heated debates among scientists. For decades, the Big Bang Theory was the cornerstone of the universe. This is a model that shows the universe as a whole from heat, the first time in 13.8 billion years. This expansion is what we measured, what we learned, and what we derived from our understanding of the world. The Hubble constant, a key value that characterizes the speed of this expansion, is at the heart of our calculations. But there is a problem, one that the James Webb Space Telescope has made clearer. The measurements are not the same. Local measurements and previous Hubble measurements are in conflict, and the JWST data deepen the puzzle. Imagine looking into the depths of space and hoping to confirm something you already know, only to find something different. This happened when scientists analyzed the last image taken by JWST. It's not just a picture, it's a revelation. The clarity and detail provided by the telescope allowed scientists to see aspects of the universe that were previously hidden, and what they found was both exciting and terrifying. This image has taken hold in the far reaches of space, but also in the minds of the scientific community. It's as if the world itself threw a beam, daring to rethink everything we thought we knew. This picture has shown the differences that cannot be ignored, and because of these differences, the whole world of the world has been destroyed. The main problem at the heart of astrophysics at the moment is this: scientists cannot agree on the age of the universe and the rate of its growth. These are not trivial questions. They are the basis for our understanding of the world. The problem lies in the different methods used to measure the Hubble constant. Local measurements, which study astronomical objects such as Cepheid galaxies and Type I supernovae, show that the universe is expanding faster than previously thought. On the other hand, measurements taken from the early universe, especially through observations of the cosmic microwave background, CMB, the light after the Big Bang, tell a different story. These conditions indicate a rapid rate of expansion. Scientists have been trying to resolve these differences for years. They've re-examined their data, refined their methods, and even asked if new physics is at play. But now, with JWST data, the situation is more complicated. Instead of clarifying things, the telescope's observations have introduced new variables that don't fit our models. It's like working on the same puzzle for decades, only to find that some of the pieces belong to a completely different puzzle. The universal concept is not new. It was at the beginning of the 20th century when Edwin Hubble made his groundbreaking discovery that galaxies were moving away from each other. This discovery led to the development of the Big Bang Theory, which states that the universe began from a small, infinitely dense point, a singularity, and that from then on the universe continued to grow. For decades, this concept was the most important model in the universe. It's a theory supported by a lot of observational evidence, from the redshift of galaxies to the distribution of the microwave background. But this is a theory that is being challenged and modified as new data becomes clear. In 1965, the discovery of the CMB provided solid evidence for the Big Bang Theory. This is a very important moment in the history of the world, which confirms the idea that the world had a beginning. But as with scientific theories, new discoveries often raise new questions. When scientists realized in the late 1990s that the universe was not only expanding, but accelerating, it added a new layer of complexity to our understanding. This acceleration was attributed to a mysterious force called dark energy, a cause that is not fully understood. Dark matter and dark energy are two of the most obscure concepts in modern cosmology. There are forces that we cannot see, but their results we can see. Dark matter is estimated to make up 27% of the mass and energy of the universe, but neither emits nor absorbs light, making it invisible to our eyes. We infer its existence from the influence of the influence on observables, such as galaxies and galaxy clusters. Dark energy, but more mysterious. It is believed that he is responsible for the acceleration of the universe, but we do not know much about it. An unknown force enters space that causes galaxies to collapse as they accelerate. JWST is expected to shed new light on these dark parts of the universe. The clarity and simplicity of the past help us refine our measurements of the universe's expansion and distribution of matter. But instead of providing answers, the JWST data has raised more questions. It seems that the world is more complicated than we thought. In an attempt to solve these mysteries of the universe, scientists have embarked on ambitious projects like Project Flamingo. The project, which is supported by one of the world's most powerful computers at the University of Durham in the UK, aims to balance the world in neutral information. The goal is to model the entire spectrum of cosmic elements, from galaxies to dark matter, in an attempt to resolve discrepancies between our theoretical models and observational data. Project Flamingo is a symbol of the scientific community's desire to understand the world. This marks a new frontier in computer science, which may lead to groundbreaking discoveries. But even with its sophisticated simulations, the project has not yet solved the problems in our understanding of the world. The constant insistence on correcting different measurements of the universe's rate of expansion and distribution of matter is a humbling reminder of how much we don't know. Despite our progress, the world continues to resist our efforts to understand it. It's like the world is hiding some of its secrets, and it's revealing itself when we have to find it. We stand on the brink of a potential paradigm shift in the planet. It's good to wonder what the future holds. The differences in our measurements suggest that there may be new physics waiting to be discovered, new laws that will change our understanding of the universe. Of course, we need to revise our current models or develop new tools and methods to explore the world. JWST has opened a new chapter in our space exploration, one that promises to be as exciting as it is challenging. The data will be analyzed and discussed for years to come, and may lead to discoveries we have not yet imagined. But one thing is certain, this journey is not over yet. Each new observation, each new data, brings us closer to understanding the true nature of the world. The pursuit of knowledge is a never-ending journey, one that humans have been on for thousands of years. From the first astronomers charting the stars to today's scientists exploring the farthest reaches of space, the quest to understand the universe has been a constant in our history. And with the James Webb Space Telescope, the effort has entered a new era. JWST has provided a window into the world like never before. Pictures are not just pictures. It is a symbol, a reference to the deeper truths that lie in the fabric of space and time. But when we look through this window, we must be prepared that what we see will challenge everything we thought we knew. The world is a puzzle, and new discoveries are part of that puzzle. But unlike the old puzzle, this puzzle has no clear edges or boundaries. It's a puzzle that increases in difficulty with each new piece we add. And as we continue to explore, we may find that some parts don't fit, and some of our ideas need to be re-examined. But that's the beauty of science. It's a discovery process, constantly improving our understanding based on new evidence. It is a journey that takes us out of the world and deep into the heart of the atom. A journey that challenges us to think, to question, and to explore. So, as we continue to uncover the mysteries of the universe, we do so knowing that there will be many more to discover. The world is big, and our journey has just begun.